Good morning, class, and welcome to discussion number 5, where we'll be learning about templating. We'll first cover what templating is, why it's useful, and some applications of templating in EECS 280. To start off, let's turn our attention to this snippet of code I have on the screen, where I am accepting two integers, and I am returning the minimum between the two. It works as we expect it to, and if we simulate it with this executable below, say we have two integers, x and y, where x is 2 and y is 3, and we call getMinimum on x and y, and we print it, this should print 2, right? Now let's say that we have two doubles. Double A is equal to 4.1 and double B is equal to 3.3. And again, we print the minimum. So we call getMinimum on A and B. Right. So the question I have for you now is, can we still use the same getMinimum function that we've used for the integers to print the doubles, to return the minimum of doubles? And the answer is no, because the original getMinimum function signature takes in integers as inputs. If we do getMinimum on doubles, we would get a runtime error. One solution to this would be to write a completely new function that has the same exact code structure, but instead of taking integers as inputs, it would take doubles as inputs. So how this would look, our return type would be double. We would have the same function name, getMinimum, and this function accepts two inputs, two doubles as inputs, so double A, double B, and the implementation remains the same. So if A is less than B, we return A, else we return B. Simple enough, right? And now if we execute the code we had before, two doubles, and we print the getMinimum between A and B, this should work as expected. Okay, now to emphasize the big picture here, let's take a step forward and consider a more involved scenario, right? So let's say we had a vector of nodes, right? Or some custom type, custom class, and we wanted to write a bubble sort algorithm to sort the element in ascending order. For the sake of the example, let's suppose that we wanted to use the getMinimum function that we had previously, right? We wanted to use the getMinimum function we have written to compare two elements, find the minimum between the two, and then swap. However, it seems like once again we ran into the issue of incompatible types being used in the getMinimum function. We have one for integers, we have one for doubles, but now we need another separate function that accepts nodes. I think at this point it's pretty clear that we would end up with a lot of unnecessary code duplication and redundancy. A more elegant solution, you might have guessed by today's topic and what we're discussing, is templating. Right. So now that we have some basic intuition behind the purpose of templating, let's go over the syntax and see how it operates under the hood. So to write a templated function, we first have this header. We first want to write template class and then an identifier, so like a generic name for the type that we are passing in. So let's call this my type. And then we proceed on with our function, our templated function, right? The return type of this function would be my type, or whatever you name the identifier that you give for the generic type. Then your function name, which in this case is getMinimum, which accepts two inputs of type, my type, the generic type, so my type A and my type B. But again, the code should remain the same. If A is less than B, if A is less than B, we return A, else B. So pretty easy. Now, if we wanted to use this function template, we have to follow a specific format for our function call, which is as follows. So we first want to have our function name, then our generic type enclosed in angle brackets, and then the parameters of our function. So again, taking off from our previous example, we have two nodes, right? Node X and node Y. Now, we would call getMinimum, have our type enclosed in angle brackets, node, and then our parameter, X and Y. So now we return the minimum between two nodes, given that we have the less than operator overloaded for this node class that we have, right? And so under the hood, when you make a call to getMinimum, the compiler uses the template to generate a function that replaces each instance of the identifier type, in this case my type or node, with the type passed into the function. So for example, getMinimum on node xy, the compiler creates this new function and replaces my type in the templated function with node. So take a look here. My type becomes node. My type becomes node. So clearly, every instance of my type is the identifier is replaced with node, since node is the data type being passed into the function. And in essence, the compiler does all the heavy lifting for us and saves the programmer from having to write messy and redundant code. We now have like the capabilities of extending our getMinimum function to accept inputs of any type and compare them regularly if the functions were like primitives, or use an overloaded operator if we had custom types. And so to give another example of where templating would be useful is in Project 4, where you would be asked to implement a binary search tree. In a binary search tree of what, you may ask? It could be binary search tree of integers, doubles, or any particular type. However, the point is to avoid having to write every function, having to rewrite every function multiple times in order to accommodate for like all the different data types. All the different data types you can store in a binary search tree. We could simply just slap on a template and have one function to serve all the data types. So insert is one function, delete is one function, print is one function, and we only need one to accommodate for all these different data types. And to conclude, templating is a great tool to generalize functions to multiple types, and you will encounter it more in the future of object-oriented programming. Thank you for listening. This is the end of today's lecture. Thank you.